method is write an equation to fit the line. So this is what you weren't able to do last night. The one slide we didn't get to yesterday. You got it. If a function is linear, then it has the same slope all the way up the line, right? It's a fourth, or whatever the slope is. So that's how I'm going to determine if this data is linear. I'm going to look at the slopes. So what I noticed pretty quickly is these are all going up by 1. So that'll be easy because then I'm just dividing by the y2 minus y1 divided by 1, right? So how much does this one go up? What about this one? This one? So aren't the slopes all 3? 3 over 1, 3 over 1, 3 over 1, 3 over 1. This is linear. It is a linear equation with a slope of 3. Now that tells me to write the equation of the data. If I know the slope 3, can I write an equation? What else do I need to write the equation? The point, I think I have 7 of them. Just pick one. So y minus 6 equals 3 times x minus 2. That is the equation of the line with those points. If you want to do it. If it didn't tell me I had to, but if it did tell me, which it might on the homework read the directions, if it did tell me I needed it in slope-intercept form, then I would distribute the 3 and add the 6 over, so I would get y equals 3. So either way. Both of those answers, it doesn't say that I could take either or. The next one. Notice all of the x values are going up by 2, so I'm dividing by 2 each time. This y goes up by 2. This one goes by, okay, so that slope was 1, 2 over 2, right? This slope was 7 over 2. Is that the same? Not linear. And if it's not linear, I can't write an equation of the line because it's not a line. Any questions on that one? One other mental note. If the problem asks you to find the average rate of change, what's it asking you to find? Slope. Well, on the problem on your homework, it only gave you x values. This is not your homework problem. I'm making one up. But say it gave me x is 3 and x is 5. And it asked me to find the slope. What do I need? What do I need to find the slope? I need y values, right? So how would I get y values? Plug in the x's into the equation they gave me to get y values. So the y value for this point would be 9. And the y value for this point would be 25. Again, this is not your problem. I made this one up. So then you would do y2 minus y1 over x2 minus x1. Does that help with that homework problem? If you have a question on that one. Alright, so that should kind of finish that up. So we are going to start algebra functions today. This would have been your bell ringer, but we kind of have problems. This will be a 2-day lesson. You will get a worksheet today. It will be due on Tuesday, but it's long, so you want to do as much of it as you can today, and then Monday we'll finish it up. You'll kind of see how far I am teaching. I'll show you how many slides are left. Monday may end up being partially a work day. You will also get your review though on Monday, and you'll want to start working on your test review. So that's some things that are coming. I'm also going to hand out today a copy of your mastery exam. If you are unfamiliar with that word, I'm going to explain that to you while you're working this problem. All of the math classes at Greenwood High School have started doing what are called mastery exams. Mastery exams are where you take a test over and over again until you great grade booster. Because you're all going to get a 50 out of 50 on it. Because you're all going to make 100. Because you get to take it over and over again until you do. So it's a wonderful grade booster. Those of you who need a grade booster next week, you're going to get a chance to get a 50 out of 50 on a quiz grade by taking it over and over again. The other amazing thing about it is me and Mr. Billingsley made these master exams together, and we've seen the college algebra final. So what we did is we pulled the most important skills, the skills that we know you have to know, or you're not going to do well on the college algebra final. And that's what we put on these mastery exams, so that you're going to get those skills that you need to know, and you're going to get them very, very well. So that's a couple of awesome things about it. Now, they can be frustrating, because you have to take them over and over again until you make 100 of them. But just know, it is for your benefit that we're doing it. It's not just to make you come take tests over and over again. It's because as math teachers, we know there are skills that you cannot live without and be successful in math class. So we pull those skills, those most important skills. They're also very important ACT skills in this class. And so we're going to learn those through this mastery exam. You can come sit in here and work it, and then when you're done, you can ask me questions about it. Then you can try again immediately. So that's kind of how that will work. So next week we will take that for the first time. But I'm going to give you a copy of it. It is not the same numbers, but other than numbers being different, it is the same type test. So I'll give you a copy of that either today or Monday. So you'll get a copy of that at some point soon. Any questions about that? That's coming next week, and your test is coming next week. So you have 2 opportunities for your grade to completely change next week. If your grade is low, if you do well in both of those things, your grade will go up a lot. So, which one of them you're guaranteed to do well on. Some good news for grades coming up next week. F of -2. How am I going to do F of -2? We're going to put -2 in where x is. -6 minus 2, which is. Any questions about that? F of 5. Three times 5 minus 2. And so what would F of 2 plus F of 5 be? And how do we get that? So today we're going to be talking about what's called algebra of functions. We're going to be adding, subtracting, multiplying, dividing, and doing composition of functions. So that's what we'll be looking at today. How many of you remember seeing the F of G stuff? Maybe on an ACT or in another class. So this is where we're going to learn how to do that. Before we do that, we're just going to do adding, subtracting, multiplying, dividing. When you see F plus G of X, it does not mean F plus G times X. It means F of X plus G. So this really means F of X plus G. All that means that they're teaching kind of gets people, sometimes they try to multiply X by it. So it doesn't mean F plus G times X, it means F plus G of X. And so X is just a variable. So F of X is 3x minus 2. G of X is 4 minus 2x. So F plus G of X is X plus G. Just combine like terms. Any questions so far? Not too bad, right? So now let's do F minus G of X. Anyone remember something from algebra 2 we have to be careful about on f minus g of x? So I know it's just f of x minus g of x, which is 3x minus 2 minus 4 minus 2x. You want to do a problem with that? There's a problem. We have two memories. Good. I need to subtract all of g of x, don't I? As this sits, I'm only subtracting the 4 and not the 2x. So, when you're doing subtraction, make sure the second piece is in parentheses. Start that in your notes. This is not a hard skill, but if anyone messes it up, that's one place they mess it up at. It is by forgetting that parentheses. So what does a parenthesis with a negative in front mean? What do you think with that? You distribute that negative so the 4 gets the negative and the 2 gets the negative, which makes the 2 positive. So you distribute that negative into that parenthesis. So now I get 5x minus 6. Any questions so far? The next one with a little dot, what does the little dot mean in math? Multiplication. So f times g of x. Again, this means f of x times g of x. And I want to say this one more time because for some crazy reason, students try to multiply an extra x. Remember that x is not multiplication at all. It is just saying f times g of x. So we're just going to do f of x multiplied by g of x. How do you multiply two things that are multiplied, two things with two terms of two binomials? You need parentheses. FOIL it. Or if you had Miss Lowe do something other than FOIL it, very much resembles. Distribute or FOIL. You're going to multiply everything in the first parenthesis by everything in the second parenthesis. So 3x times 4 equals 12x. 3x times negative 2x gives me negative 6x squared. Negative 2 times 4 gives me negative 8. And negative 2 times negative 2x gives me positive 4x. Combine like terms. Something else I want to mention on this. This has asked me to find f times g of x. It has not asked me to solve it. So, do I need to do any more work? I don't need a factor. I don't need to find x. In fact, I would be wrong if I did, because it just told me to find f times g of x. Yep. I simplify it by combining like terms, but that's all. The reason we would factor is to solve, and it doesn't have to. F divided by g of x is f of x divided by g of x. That's what that means. Which is 3x minus 2 over 4 minus 2x. There is no simplification that you know how to do for division. So on the ones that are divided, you're always going to stop here. Later in this class, we'll learn how to simplify fractions. But right now, you don't know how to do that. And you would probably do it incorrectly. So, okay. Any questions? So that is algebra functions with an x. Now we're going to look at algebra functions with other things besides an x. These are different functions. Not I do we are not using the same thing we did on the last slide, not the same F and G. If F plus G of X and F of X plus G of X, what do you think F plus G of 1 means? 1 goes to the X's. This means F of 1 plus G of 1. Which feels a little bit like what we did on the separator, doesn't it? That's why I had to do that the second one. So F of 1, can I find F of 1? What is F of 1? 2. 4 minus 2. 4 times 1 minus 2. Everyone see how I got F of 1? 4 times 1 minus 2. And what's G of 1? So F of 1 plus G of 1 is 2 plus 2, which is 4. Now, could I have found F of X minus or plus G of X and then plugged it in? I could, but it would take me longer. So if it's F plus G of 1, might help. So to find F of 1, I did 4 times 1 minus 2. See, I got that. And then to find G of 1, I did 3 minus 1. So how do you think you do F minus G of 3? Perfect. I do F of 3, and I do G of 3. That's correct. F of 3 minus G of 3. Again, I want to say it one more time, and you might want to write this in your notes. Do not multiply by 3. Okay. Everyone see what I mean by that? That 3 is the X value. We're not multiplying by 3. We don't get an answer and then multiply by 3. We do nothing times 3. Don't do it. You know that there's a reason I'm saying that, because like half of you will try to do that. Don't do that. Don't multiply. So F of 3 minus 2, which is 10. And G of 3 is 0. So here's how I'm getting those numbers. F times G. Put a number. Number. We'll do it. F times G of X. But if I had a number and you put a number in, maybe I was trying to trick you guys. F times G of a number, I'd put a number in both and then multiply. This one is not F times G, it's like a number. It's F of X times G of X, which is 4X minus 2 times 3 minus X, which is first, outer, and last, 12X. Combine like terms and then stop. Did y'all get that? Okay, and then F divided by G of 2 is, what do you think it is? What does that really mean? F of 2 over G of 2. F of 2 is 6. I don't know where I'm getting that. 4 times 2 minus 2. And G of 2 is 1. Any questions about adding, subtracting, multiplying, or dividing? big thing is making sure you know what the notation means. If you know what the notation means, it's not a hard problem. That's where most people get confused because what this means. Now we're going to talk about a composition of functions, which this is probably the part y'all wanted to see, have seen it on an ACT, maybe it was something you didn't know how to do, so this is a big part for today. Composition of functions is when you put one function inside another. Now, some of you are going, why are we doing this? Most of you are going to go into some field in the business world. You're going to use Excel to do things. Whether you're a science person or a business person or any of those things, you're going to use Excel to do things. Well, say we wanted quarter one profits and quarter two profits added together. Well, what's that? That's f of x plus g of x. If you understand that, you can write an Excel function that does that for you. So that's where you would use this, is to write Excel, make Excel do things for you. My husband's an accountant, and I always tease that he could make Excel tie his shoes if he felt like it. Because he can make Excel do anything almost, it feels like. And so that's where you would use this in the real world. So let's talk about what a composition of functions is in the real world, because you can imagine adding, subtracting, multiplying, and dividing, what you use those things for. So let's talk about what a composition of functions does. It puts a function inside a function. The best example I have is probably if you've been in a physical science or chemistry class, and you had to convert Fahrenheit into kelvins. And what did you have to do that? Not the actual steps, but what do you have to do first to go up to kelvins? Convert it to Celsius first, right? And go from Fahrenheit to Celsius and Celsius to kelvins. Well, if your science teachers were good math people, they would have given you a function that went straight from Fahrenheit to kelvins. And that's what a composition of functions would do. You can compose those two functions you have. You have one that converts from Fahrenheit to Celsius. You have one that converts from Celsius to kelvins. Well, if you had a math person doing that, we would never use two functions. We'd make one. By composing those two functions, make one, do it all. So that's what a composition of functions does. It composes two functions. It makes you do two things at once. Does that make sense? So that's what composition of functions is. So how do you read it? This is not a multiplication symbol. Multiplication symbol is just a dot. So make sure that you get those straight in your head. The dot means multiply. The open circle means composition of functions. And what f of g of x, that's how you read it, f of g of x. I'm going to write it how I read it, because this notation does not make sense. But this notation does make sense. So I'm going to rewrite f of g of x as f parenthesis g parenthesis x, which reads f of g of x. We're going to work that from the inside out. If you see g of f of x, that means the g is the outside function and the f is the inside function. So that's how those work. That is a composition of two functions, a function inside a function. So we're going to work some examples. I'm going to start by finding f of g of x. Every time you see a question like this, the first thing you need to do is rewrite it, because that notation means nothing. It's very hard to work with. So I'm going to rewrite this as f parenthesis g parenthesis x. First step. Everyone do that with me. On your homework, I want to see that step. I won't always make you show that, but for now, I want to see that step. Give myself a little more room on my notes. f of function g of x. Right? So I'm just going to rewrite g of x with the actual g of x function. And so now this reads f of 4 minus 2x. Time out. How in the world do I do that? So how did I find f of 1 earlier? You put 1 in for x. How would you find f of a million? You put a million in for x. How would you find f of smiley face if I made you do that? You would put the smiley face for x's. So how do you think you're going to do f of 4 minus 2x? You're going to put 4 minus 2x where you see the x. So I'm going to write f. I'm going to color code it for right now. Okay, I wrote f, but what did I not write down? I didn't write the x because I'm not going to put x there. What am I going to put there instead of x? Does that make sense? Y'all remember doing this in Algebra 2? We'll go ahead and simplify it, but other than that, that'll be our answer. Do y'all remember having a difficult time with this? Does this make sense? Awesome. Got it? Okay, so we're going to put the 4 minus 2x in where that x was. So for now, I want you to show these steps. Yes, there will be a time when you can do this in your head, and that's fine, but for now, I want to see those steps. On the test, show the steps, because if you do make a mistake, I can give you some partial credit for that work. I am going to simplify, but that's all I'm going to do, just simplify. 12 minus 6x minus 2. So that is f of g of x is negative 6x plus 10. That's f of g of x. I'm not going to do any solving. Didn't ask me to. In fact, I don't even have an equation to solve. It doesn't say equals anything, so I can't solve it even if I wanted to. Don't try. It's out there. So now let's try g of f of x. From here, the negative 6x was here, and here 12 minus 2. So just combining like terms. So now I'm going to do g of f of x. Again, the very first thing I'm going to do on g of f of x is write it to where I can understand it. That doesn't make sense, so I'm going to rewrite it to g of f of x. I'm going to work from the inside out. So I'm going to replace the f of x with f of x. Someone who did someone write the problem down. What was f of x? I'm going to say it again. To do g of 1, I'd put 1 in for x. To do g of a million, I'd put a million in for x. To do g of smiley face, I'd put smiley face in for x. So to do g of 3x minus 2, I'm going to put 3x minus 2 where I see the x in g. So someone tell me what was g? 4 minus 2 blank. Right? Where that blank is, I'm going to put 3x minus 2. Notice there's not an extra x in there. It's not blank and x. It's where the x was. I'm replacing it with the 3x minus 2. Makes sense? Simplify 4 minus 6x plus 4. So I get negative 6x plus 8. Are f of g of x and g of f of x the same thing? Back it. No, they're not. So composing functions in a different order gives you a different answer. So when you read f of g of x, you do have to do the correct one on the outside, the correct one on the inside. Any questions so far? Now, the next question one or the other, not both questions. So it's a little easier with numbers, just like it was with adding and subtracting. So I'm going to show you how to do composition with a number. The first step is always to do what? Rewrite it. Write it how it makes sense. So f of g of what? Negative 1. This time the x is negative 1. So it's f of g of negative 1. I'm going to work from the inside out. What's the first thing I see on the inside? G of negative 1. Can I find g of negative 1? Where would I go to find g of negative 1? Up to the equation, and I plug negative 1 in for x. So g of negative 1 is 4 minus 2 times negative 1, which is 4 plus 2, 4, 6. And negative 2 times the negative 1 is positive 2. 4 plus the 2 is 6. If you need a calculator to check something like that, use it. It'll give you that correct value. So if g of 1 is just 6, hence I just put 6 here. And then can I find f of 6? I'm going to go up there and I would do 3 times 6 minus 2. Is it the same thing I would have gotten there if I plugged in negative 1? Negative 1 times 6 with negative 6 would be positive 6. Positive 6 plus 10 would be 16. So I did the same thing. Now again, if you already have that sitting there, that's probably what I would do, but most of the time these will come by